Welcome to today's Explainer. I'm just incredibly excited to share this one with you, mainly because we're going to explore a profound historical mystery. And the craziest part? It's literally sitting right inside your refrigerator as we speak.
Think about tomorrow morning. You might open the fridge, grab a carton of milk, and just pour it over your cereal, maybe add a splash to your coffee. That whole thing takes what, 5 seconds? You probably don't even think about it. But here's the hook. The strange part isn't that you drink milk. It's that your adult body can actually digest it. You see, biologically speaking, adult milk digestion is a total historical anomaly. For the vast majority of human history, producing large amounts of lactase into adulthood, that was simply not the normal human condition.
So let's define what's actually going on here. Lactase decline. This is the ordinary biological shutdown of the lactase enzyme at the end of infancy. And this is super common across most mammals, including, historically, most humans. I really want to make this clear. This is not a defect. It's the standard mammalian operating procedure. Once a mammal is done nursing, the enzyme that breaks down milk sugar just quietly winds down. Why? Well, because the body figures, hey, no more milk is coming. But as we'll see, humans didn't exactly stick to that script.
Section 1. Herds as living infrastructure. The ancient shift from meat to milk.
Okay, let's dive into this. How did early humans break this fundamental biological rule? Well, to understand that, we have to travel way back, about 10 to 11,000 years ago, to the Fertile Crescent. This is that broad arc of land running through parts of modern Turkey, the Levant, Iraq, Syria, and Iran. This is exactly where people first began domesticating goats and sheep, with cattle following pretty shortly after. Now keep in mind, this wasn't some sudden overnight event. It unfolded gradually as communities shifted from just following wild herds to actually keeping and managing their own animals. At first, these early herding communities mostly used animals for meat. But dairying introduced a profoundly different economic paradigm. Think about a slaughtered animal. Killing an animal gives you food exactly once. It's a single, finalized transaction. But a milked animal, that's an ongoing relationship. A living, lactating animal provides renewing resource. It replenishes itself as long as the animal is fed, protected, and allowed to breed. The herd literally stops being a stockpile of future meat and becomes this living, breathing infrastructure.
Managing that living infrastructure brought a whole new set of daily demands. Herders had to time offspring and breeding so milk was available year-round. They had to constantly protect their herds from predators and illness. And, crucially, they had to balance the calf's needs against human collection, taking just enough milk without starving the young animal. What absolutely blows my mind here is that these ancient herders didn't have math, or writing, or spreadsheets to do this. They pulled it off purely through the close, sustained observation that you only get from living alongside the exact same animals for years and years.
Section 2. Solving the digestion problem. How culture moved faster than biology.
Those brilliant observations brought them face to face with a massive twofold problem. First, fresh milk spoils incredibly quickly. And second, as we covered, most adults biologically couldn't digest the lactose anyway. So how on earth did they pull us off? They solved it through processing. Early communities essentially bypassed their own biological limits. Step 1, they collected the fresh milk. Step 2, they separated the liquid whey from the solid curds. And step 3, they stored and transported the lower lactose cheese. This is an absolute game changer because lactose dissolves mainly into that liquid whey, so a solid block of cheese ends up carrying only a tiny fraction of the milk sugar. By making cheese or fermenting the milk, they turned a fast-spoiling liquid into a durable food, without even knowing what biology or lactose was. By roughly 6600 to 6400 BCE, we start seeing the earliest secure traces of dairying in places like Anatolia and the Iranian Zagros. Researchers actually figure this out by finding dairy fats preserved right in the carbon isotope signatures of ancient pottery. And what's super fascinating is that Anatolia focused mostly on cattle, while the Zagros focused heavily on sheep and goats. This tells us dairying wasn't just a single light bulb moment that spread outward. It was a shared pressure. Different people in totally different landscapes facing the exact same challenges independently arrived at the same brilliant solution.
Section 3. The Great Biological Delay. Drinking milk without the genetic tools. Now, what's really interesting here is the massive twist in our story. People were drinking and processing dairy long before they evolved the genetic tools to actually handle it easily. Let's just trace this timeline for a second to realize how enormous this quiet gap was. Domestication begins over 10,000 years ago.
Then there's this massive 2,000-year gap before we see the first secure evidence of dairying in 6,600 BCE. And honestly, they were probably doing it even earlier, before pottery was common enough to leave evidence. Thousands of years go by where people are literally building their entire lives around dairy.
I just want this idea to really sink in. Culture moved first. Biology followed much, much later. The cultural practice of dairying, driven entirely by human ingenuity and generations of observation, predated the biological ability to digest lactose by thousands and thousands of years. It's kind of wild when you think about it.
We actually have incredible proof of this from a site called Banbury Lane in Britain, which dates back to around 3800 to 3900 BCE. Scientists looked at the hardened plaque, the dental calculus on ancient teeth found there, and they actually discovered milk proteins. So we know for an absolute fact that these specific people were consuming dairy. But here's the kicker. When researchers genetically analyzed 3 people from that very same site, literally 0 of them carried the genetic allele for adult milk digestion. It's a perfect snapshot of a population eating dairy without the biological tools to easily digest it.
And that leads us directly to this truly shocking number, 7.1%. Fast forward to a Bronze Age battlefield in Germany called Tollense, dating to roughly 3,200 years ago. Researchers analyzed the DNA of the individuals there, and only an estimated 7.1% of that sampled population carried the principal European lactase persistence allele. Only 7%. By the time of this battle, dairying had already existed in Europe for more than 4,000 years. The cultural practice was ancient, but the genetic adaptation, still incredibly rare.
Section 4. The push for evolution. Why did the genetics finally change?
Let's see how this builds, because this leaves us with a pretty big lingering mystery. If people were getting by just fine by making cheese and fermenting milk for millennia, what finally pushed our evolution forward? Why did the genetic trait to digest raw lactose suddenly spread so rapidly? To answer that, let's formally define the exact trait we're talking about. Lactase persistence. This is the genetic ability for adults to continue producing the lactase enzyme and easily digest milk sugar. This is the biological tool that finally, eventually caught up to the established cultural behavior of dairying.
And you know what's amazing? This biological leap wasn't just some one-time fluke. Lactase persistence evolved independently multiple times. Different groups herding different animals in totally different environments arrived at a similar biological outcome through completely separate genetic paths. We see a principal European variant, several distinct African variants, and Middle Eastern variants. Evolution was basically working overtime across the globe. But why did the gene spread so aggressively once it appeared? One obvious guess is milk's high caloric density, right? It's great energy, but a major study actually points in a much darker direction: famine and infectious disease. The prevailing theory right now is that during really hard times, people who drank milk despite lacking the allele suffered from worse illness, leading to higher mortality. So the allele didn't just spread because milk made healthy people stronger. It spread because the biological ability to safely digest milk spared sick or starving people from a much worse fate during brutal historical famines. Which brings this whole explainer full circle. As the source material so perfectly puts it, the strange part is that any adult can keep digesting its lactose with ease at all. Pouring milk on your morning cereal really is a remarkable historical anomaly. It's the end result of thousands of years of ancient herders carefully observing their animals, innovating through cheesemaking, and then waiting millennia for human genetics to finally catch up. It's just an incredible story of human culture driving biological evolution. And honestly, it leaves me with one final provocative question for you to ponder. If a simple glass of milk actually changed our DNA, what other mundane daily habits have quietly reshaped human evolution? Thank you so much for joining me for this explainer. Keep wondering, and I'll catch you next time.